In this example, we're going to match to a load resistance of 20 ohms, which is a normalized impedance of 0.4. Okay, so this will be a normal L match, and we're going to start on the Smith chart here. Step 1 is to start here at our load impedance. Now our load impedance is such that the first element we add should be in series to increase that impedance, and so we don't need to flip it first. At first we're just going to move this way, and we're going to get to a point such that when we flip, we end up on the R equals 1 circle. Okay, so now flip from this point 2. To get to point 2, what did we add? We added a capacitive reactance component. We're adding reactance because we have not flipped. We're still in series. And that value was around 0.48 or 0.49. Okay? All right, so now we're here. The next thing we want to do is add something in parallel. Okay? We have our load resistor, and we added a capacitor. The next step is to add something in parallel. We're going to flip up to somewhere around in here. Okay? And what you should see is if you take a ruler and you draw a line from here to here, that matches. Okay? So now that we're here in step 3, we're going to go to the origin along the constant R equals 1 circle and have our match. Okay? To go from point 3 to the origin, we are adding, let me zoom out some. We were here, right, and we moved into here, and so we added this susceptance, right, and the susceptance we added was going in this direction, so it's an inductive susceptance. Okay? So we have an inductor in parallel, the susceptance of about 1.2, a capacitor in series, and our load resistance. Okay? This load resistance is 0.4. This impedance is around 0.49. Okay? And this susceptance is 1.2, so the impedance is 1 over 1.2. Okay? And so if you check the L match equations, you're going to get about these numbers, okay, of 0.82 for the impedance that's added here. Okay, so this is our match where we started here, went down to here, we flipped to there, and to there. Okay. Again, we always want to end at the origin for a reflection coefficient of 0.